So today, a couple of minutes on GCF and grouping. Should be mostly review, although the grouping one might be a little bit new or just something where you see it in a different context. Okay, so GCF, greatest common factor. This one is the most important one because you should look for it and do it every time. Okay, you should always look for this. You're going to have equations, things to simplify in the future. Look for a GCF. It'll make the problem easier. Now, there will be some problems where you could still solve it without doing a GCF, but it'll be much harder. So GCF not only is sometimes the only option, but other times it just makes it easier. All right, so GCF is what you should look for first. It's always the largest number that can divide into all the given numbers, both number and, I should say, variable. Variable with the smallest, yeah. So if there's variables in there, it's always the variable with the smallest exponent, and then the largest number that you can divide in. So we'll see those in a minute. Actually, let's just do number one. And by the way, I have this, so we're just going to page 1 here with this, with method 1 and 2. I'm not going to do all of them. I'm just going to do some until I think that we got it, and then we'll move to some practice. So let me go ahead and hit GCF. Let's do number 1. So I look for, you might already know, it says factor completely. So you might already know what the GCF is. But really the strategy with the numbers is look for the largest number that's a multiple of both of those. So 3, right? You can never, GCF of 1 is never going to happen. It won't do anything. 9 is too big. It won't divide into 3 evenly. So here's what I list the 3 out there. That's what my GCF for the number is going to be. And then for the variables, I have an x squared and x related to the first power. So I take the smallest one. I can only pull out an x. This one has x times x. This one only has 1x. So I pull out an x. Now I don't know if your teacher in the past did this, but I like to write it like this. What I'm really doing with a GCF is dividing. I'm dividing each of these by my chosen GCF. And that's the result. I started doing this a few years ago because I was like, it helps students see it. So really what I'm doing is 9 divided by 3. And I get 3. X squared divided by x. That's x. Minus, then here they cancel, and so just 1. 3x divided by 3x is 1. Okay, so that would be the completely factored form for that problem. Bless you. Now, a lot of these I'm not going to have answers provided because you can check your answer by doing what?
Distributing.
So if you distribute, or if there's multiple terms, you might need a FOIL. 2 binomial terms, you might need a FOIL. But that's how you can check all of your answers. Okay. Let me take it back up. No, let's do another one of these actually first before I do grouping. Let's do 4. Was there any questions on 1? Good there. Okay, let's do 4. So let's start with the numbers 55, 11, and 44. I try and do a GCF, and there is one. What's the biggest number? 11 that I can take out. What about p squared? What is that? P to the 7th and p to the 5th. P squared. So then again, you don't have to write this part. I just like to. Then I'm really dividing everything by 11 p squared. 50, then you just divide. 55 divided by 11 is 5. P squared over those cancel. Minus, the 11's cancel there. P to the 7th over p squared. What's that? By the way, if you're ever wondering, really, so you subtract the exponents when you're dividing. When you're dividing variables with exponents, you subtract the exponents. Really, it's because there's really 7 p's on top. 3, 4, 5, 6. And on bottom, it's p times p squared. So you can cancel 2 of those, but you still have 5 left over on top. So you just subtract to make it easier. Last one is 44 divided by 11, that's 4. P to the 5th over P squared, I subtract, it's P cubed. One other thing I wanted to mention here, if you ever forgot to take out, you know, like in the first one, if I only took out 3, I would have been left with 3x squared minus x. Then you can keep going and say, oh, I forgot to take out an x. So I bring down 3. Now I take out an x, right, and then you get to here. So you can, if you don't take out the total GCF, just a factor, not the greatest one, well, you can still keep going and do it again. How about any questions on 4? Okay. I think I'd like to do a grouping one now. So let's go back up and talk about this method. Next one we'll talk about is factoring by grouping. Now, there are exceptions to this for more advanced problems, but for our purposes, you use this when there are 4 terms. Now, you still look for a GCF first. That might be it. There might not be grouping. So don't think, oh, there's 4 terms, I'm automatically going to do grouping. No, look for GCF first. Then we'll see if it sets up to be a grouping question. What you do, I use parentheses. Your teacher might have done like brackets. You group the first 2 terms and you group the second 2. And then what happens is you do a GCF for each. And then hopefully those will have a GCF. Lots of these will work out by grouping, but it doesn't always have to. So you might do group, oh, it didn't work. Then you got to try something else. So does this sound familiar, this one, factoring by grouping? No. Maybe, no. Well, yeah, let me do one, and then we'll see what you think then. Let's do 9. Let's do 9. 4 terms. Start by looking for a GCF. So what's the GCF for all 4 terms? There is none. 1 would be the only thing, and that doesn't do anything, yeah. So there are 4 terms. Let's try grouping. What you do is what I group the first 2 terms with the parenthesis. I group the second 2. Now I include the plus in there. You don't have to actually. I'm going to do one where it's a minus, and I'll show you why I include that there. But you group each of these into a GCF just for each group. So now, just looking at the first, 6xy squared minus 3xy, what's the GCF there? 3, and then yes, xy. So just for this one, I'm going to divide each by 3xy. 6 divided by 3 is 2. X's cancel, y squared over y is y. Minus, everything cancels here, so it's just a 1. Next one, 8y and 4. Well, what's the GCF there? 4. So here's where you could have kept the positive outside, but I have a positive 4. So I divide each of these by 4. 8y over 4 is 2y. Minus 4 divided by 4 is 1. Now, is this starting to look familiar? Did you do it?
I have no idea.
Still maybe. Okay. So here's what happened is, and this was like, if you get the same thing in parentheses here, then grouping worked. If you didn't, then grouping didn't work. You're going to have to go back and try something else. Or you made a mistake. Okay. So here's why it works. Right here, we have one big term there, plus here's another big term. So there's really just 2 terms. They each have this in them, though. They each have the same thing. So what I'm going to do is factor that out. I'm factoring out a 2y minus 1. So if I do a GCF, I divide by it. Cancels there and there, and what I'm left with is 3xy plus 4. Again, here's where you would FOIL to check your work. Now, let me just show you one other thing here. Let's say I'd gotten to here, 3xy. So I'm trying to show you another reason why this works. 3xy, in place of 2y minus 1, let me call a different variable. Let me call it z. So let's say I had this, 3xyz plus 4z. I just replaced 2y minus 1 with z. If we had that, wouldn't you say the GCF is z, right? The only thing that's common there is a z. So what would we do? We'd factor out a z by dividing by it. And then you'd say, well, what's left over is, in parentheses, 3xy plus 4. I did the same thing, and you could always do this with plugging a different variable. I did the same thing, but I didn't write a z. I just left it like this. Sometimes for students it's harder because they see this big binomial term here, 2y minus 1. Questions on grouping there? No? All right. Let's do another one with a negative. It's the same process, but slightly different. So let's try, how about, that's 10. 10's fine. Okay, so I start with GCF for everything. Overall GCF, is there one? There's not going to be. There's 4 terms though, so I try grouping. Here's where I group that negative sign in there. I look at the first group, and is that an E or S? What's the GCF there? 4RS. So I like to divide by this. The 4's cancel and the S's cancel. R squared over R is R. Minus, here the R and S cancels, 8 over 4 is 2. Now here's why I grouped that negative there. What's the GCF? What's the GCF for the second group? 3. Now watch this. If I take out a positive 3, I'd be left with a negative R, and 6 divided by 3 is plus 2. You see what happened there? Yeah. It's good, it's close, but I got the opposite signs that I wanted. Because it's only going to work if the parenthesis part is the same. So you see how it's close, but it's negative R and positive 2? So what we should have done is taken out a negative 3 instead. Yeah. So if you ever get to that point and it's like, oh, I was close, well, you probably just need to take out a different sign. So I think we'll go there. So let's take out a negative 3 instead. So now it'll be a positive R left over. 6 divided by negative 3 is negative 2. And there we go. Now it's the same there, same in the parentheses.
Why does that have to be the same?
Because then, in order for you to do a final GCF, this has to be this. We're factoring this out from both of them. So that has to be the exact same in there. Just like here, I factored out the Z. Have to be the same. So right here, there's 2 big terms. The R minus 2 is what I'm factoring out. So I'm doing really grouping is GCF, what, 3 times? 1, 2, yeah, 3 times. 1, 2, here's the 3rd time. Factor out an R minus 2. So I'm really dividing by it. And I'll be left with 4RS minus 3. Okay, let's do one more for sure, but any thoughts on this 9 or 10? Okay, let's do number 12. Z cubed minus 6 plus 2z minus 3z squared. GCF overall. No. Let's group here. What's the GCF for the first one? Z cubed minus 6. 1 or nothing. Yeah, so we just had to bring that down. I just have to leave it like that. Plus, and then what's the GCF for the next one?
Z.
A single z. And I'm not going to write it up here, but we would get 2 minus 3z. Didn't work, right? Because the parenthesis part is not the same. Didn't work. What's the problem? What could we do? Because this one actually could work by grouping. Yes?
Let's say if you group negative 6 plus 2z,
Put them in a different order. Yeah, exactly. Up till now,
Wait, up here it said first two and last two.
yeah, but who says I have to keep them in that order?
It's basically just considering two. That's not it.
I just got confused because of the direction.
Yeah. So you should have done that. You should have
I guess the directions are a little misleading for this, but you're right. I did just say you're right. What is that? Bullet point 3, I said blindly group the first two and the last two. Really, I should say,
try the first two and the last two.
attempt, yes.
See if they work, then do some other ones.
There might, yes.
There might be a better one.
So basically, I should change that. It's any two you could group. Now, what's worked so far is they've all, no, they've been like R, they've been variables together. So the suggestion over here is to group a different pair. I'm going to write these in descending order. The highest exponent first. Z cubed minus 3z squared plus 2z minus 6. Then the suggestion over here was, hey, group 2z in the negative 6. And then I'll group the z cubed and the 3z squared. Now it'll work. So, group the first two and the next two. Now a GCF of the first will give us z squared. You know, what? Is it z squared, right?
Yeah.
No, I think we're just keep going.
Like, I'm
Just
pretty
keep
sure,
going.
yeah.
Just
Z cubed, what I tell you, no.
No, I wasn't talking about Z cubed.
Z cubed over z squared is z. By the way, do you guys write your little, like a slash mark through the z?
No, I don't look at you do it.
Well,
Now
unless you write your twos like this.
I don't write my things like that.
See, I think we could
Well, then
always
you
like
can-
draw straighter lines.
See, I've started to do my twos like this and my z's like that. So I need to put that in. Here, let's see, the z squareds cancel. I'm left with 3. Next group, GCF of 2. So take out a positive 2. I'm left with the z minus 6 over 2 is 3.
How am I saying it wasn't?
It
That's not what I
worked.
was talking about.
Oh.
I wrote something wrong next to myself. I said that.
The parenthesis in each pair is the same. So now I'll factor out a z minus 3 from each one. And be left with z squared.